Welcome to this brief screencast about the Java Review module feedback. I've taken a look at some of your quizzes and some of your practice, and I've got some feedback for the Java Review module. The first thing is, when I asked you guys to write a program, I saw a lot of stunned faces in the class. So I came up with this very simple programming algorithm. It's very simple. It works in general for all things. It's very basic, so let's go through it. First step, read the problem and understand the problem. What is the problem asking? What is the problem asking you to do? What does the program have to solve? Once you understand what the program has to solve, then you insert this standard Java boilerplate. You have a java.comment that briefly describes what the program does. You can have your author tag there. Then you add public class, the name of the class, which should be the program name. We've been using quiz 1, quiz 2 for the quizzes. That's fine. And then you have open curly brace. Then you have your java.comment for the main method. Again, you can describe what the program does, slightly different maybe than the general one, or it could be a copy. You add your param for the arguments, the command line arguments. Remember that args is just a suggested name. You could call it anything as long as that name is meaningful. You could use arguments. That's a wonderful term. So then public static void main open parentheses string array. That parameter name has to match your Java doc. Close paren, and then open curly brace, space for the work to be done, close your main method, and then close your class. Once you've got this down, and you should actually memorize or learn this so that it just comes out automatically, you shouldn't have to really think about it. Maybe you have to think about the name and maybe writing down what it does, but the coming up with public class and then a name and public static void main, you should be able to write that down without really thinking. Once you have the boilerplate in place, we can then add pseudocode or comments that just list the steps that you think needs to be done to solve the problem from step 1. So, like if we're counting the vowels in a string, we got to get the string, we got to then loop over the string, we then have to decide whether the character is a vowel or not a vowel, and then we count the vowels. Well, that's great pseudocode steps, but that's not enough to make Java code out of it. So the fourth step is to refine those pseudocode steps until we can replace this comments with actual Java code. So eventually we're going to have an if or a switch statement, we're going to have a for loop, we're going to have a counter, we're going to do all those things. So we got to declare the variables, all that kind of stuff. And so as you refine it, and then once you've got it down, you replace the comments with code, you have your program. So that's a very simple algorithm for writing programs. And this works in larger programs. You can do the same thing. If you have to write a program that solves a Sudoku problem, you could then have the public class solve Sudoku, public static void main, and then perhaps you defer a lot of work to other classes or other things, but you still would want to say, oh, we need to get the Sudoku, we want to then start the solution, and then we test to see if our solution is correct, whatever. It's a very good basic algorithm or steps for starting off and building your program. The next thing I noticed was some people were having the difficulty of integer math or int math versus double math. Java doesn't treat the division of ints the same way as it treats the division of doubles. So if we have an integer x, which is just 1, and int y that is 3, and a double z that is 3, and we have a double answer equals x divided by y, what is the answer? Well, the answer is a double because it's declared double. We say 1 divided by 3, and if they're ints, the answer will be 0 because 1 goes into 3 0 times, or 3 goes into 1 0 times with a remainder of 1. So the answer is 0. And that's how integer math. So if you want the real answer of a third, then you've got to somehow make either the x or the y a double. So if we then switch to say x divided by z, now we have a double on the right hand side, and so the answer is going to be 0.333, repeating to the limit of the precision of the machine. So if you want to get a true double answer from division, you need to make sure that you're going to do at least double math or float math on the right hand side. You could change the first one to be x divided by y times 1.0, which would then make the right hand side double math. But you need to do that or you're going to get integer division on the right hand side, and even though you may assign it to a double, it won't give you the right answer. And the last thing that I noticed this week is that for some of the practices, for example, calculating an average in some numbers, some people were making variables for each of the numbers and then at the end adding them together and dividing by 5. And that works, and it's a solution. It's successful. The problem is, what if I then ask you to do 7 random numbers or 100 random numbers? In order to, if you want to use that first method, you got to add more variables. Your average statement, the statement where you calculate the average, becomes longer and longer and longer, and it gets very ugly. The better way to do it would be to use a loop that loops over the number of things you want to calculate the average for. So in the second, where we use the loop, we define the sum, we define the number of items you want to average. You then loop over that number, you add the sum, and then you then calculate the average. So now if I say 7, I just change num to 7. If I say 1,000, I change num to 1,000. I change one number in my code, and I can do any number of things to calculate the average. It's much more flexible. It's easier. I only have to create 3 variables versus n+1 variables. It's a much nicer solution. So I hope this helps, giving you some feedback, some things you should think about for the Java review. Thank you for your attention.